This is a quick introduction to some software I've been writing to solve a simple macroeconomic model for the purposes of teaching. The basic model is the Keynesian income expenditure model, where consumption depends upon disposable income and taxes and imports depend upon GDP. Using this simple model, we can solve for the expenditure multiplier as shown on the slide. The parameters of the model have been estimated by some simple ordinary least squares equations and are given in the following table. These are expressed as elasticities because most of the equations are estimated in log linear form. Because the equations are estimated in log linear form, we need to convert to a linear approximation in order to solve the model. And to do that, we linearise around a particular set of values. In this case, the 2011 values for consumption and disposable income. The process of linearising is shown on the slide here, where we first of all solve for the marginal propensity to consume, and then we use this to solve for an implicit autonomous consumption C0 as shown on the final equation. The software itself is written in Liberty Basic, and the details are not readily seen by students. In fact, the program will run as a standalone package rather than students having to actually access the code. This is what students will see when they run the package. The first screen will enable them to set parameter values. For example, we can vary the implicit marginal propensity to consume or autonomous consumption levels. We can also adjust the intercepts so that any changes in the marginal propensities are consistent with linearisation around a particular point. We can also set values for the exogenous variables. For example, if we want to analyse the effects of an increase in government consumption expenditures, then we could change this by a given percentage value. Suppose we wish to change government consumption by 5%, we would enter 5 into the dialog box and click on Go. The model then solves and gives us a base solution and a new solution with a different value of government consumption expenditure. In this case, for example, we see that the 5% increase in government consumption results in a 1.22% increase in GDP, and so on. The values of the multiplier are given at the foot of the table here, in this case 1.03, very, very close to 1. The model is currently being developed, and in the future I aim to introduce dynamic effects through lags in the relationships. I aim to consider monetary policy by introducing the effects of interest rates on investment and consumption and the Taylor rule for the setting of interest rates. And finally, I aim to introduce a more detailed treatment of the supply side in the form of equations for wages, employment and productivity. But all these will be introduced with the aim of keeping the model simple for use by students and enabling them to assess the magnitudes of the effects of changes in exogenous variables on the endogenous variables of the model.